the discovery of Pluto's surprising and dynamic characteristics, made possible by the New Horizons mission, has dramatically altered our understanding of this distant world in the Kuiper Belt. When New Horizons completed its flyby of Pluto in July 2015, it captured breathtaking images and collected data that revealed an active, diverse, and unexpectedly colorful landscape. This was not the dead, icy wasteland many scientists anticipated. Instead, the mission showed that Pluto has a complex, evolving surface, unique weather patterns, and even signs of geological activity beneath its icy crust, making it one of the most intriguing objects in our solar system. Before New Horizons, our knowledge of Pluto was limited to blurry images from telescopes, including Hubble. For decades, these distant views led scientists to believe that Pluto was a static, barren rock too far from the Sun to have any meaningful activity. Pluto was long considered the ninth planet, orbiting far from the Sun at the edge of the solar system, until it was reclassified as a dwarf planet in 2006. This decision by the International Astronomical Union (IAU) was based on new criteria for what constitutes a planet, sparking public controversy and a groundswell of support for Pluto to regain its planetary status. Many were captivated by Pluto, and this only increased with the New Horizons discoveries, which showed that it was far from a mere, dead rock and much more like an active world. The journey to Pluto was one of the longest and most challenging missions in NASA's history. Launched in 2006, New Horizons traveled over 4.9 billion kilometers in nearly a decade to reach Pluto. When it finally arrived, it approached as close as 12,550 kilometers to the dwarf planet's surface, allowing it to capture high-resolution images with a precision and detail never before possible. Its onboard instruments, such as LORRI, Long-Range Reconnaissance Imager, and RALPH, a color and infrared camera, utilized the weak sunlight in Pluto's region of the solar system to capture images and analyze surface composition. These images were so detailed that scientists could see features as small as a soccer field on Pluto's surface. The data transmission was a slow process, however, and it took over a year for all the images and measurements to reach Earth. The first detailed images of Pluto's surface shocked scientists and the public alike. Far from a static, colorless sphere, Pluto's landscape appeared in shades of red, white, and ochre. These colors are largely due to the presence of tholins, complex organic molecules formed when cosmic rays and solar radiation interact with methane in Pluto's atmosphere and on its surface. But even more surprising than its color are the intricate surface features visible in these images. One of the most notable is the large, heart-shaped region known as Tombaugh Regio, named in honor of Clyde Tombaugh, the American astronomer who discovered Pluto in 1930. Within this region lies Sputnik Planitia, a vast, icy plain composed mostly of nitrogen ice, as well as traces of methane and carbon monoxide. Sputnik Planitia's surface shows polygonal structures that scientists have described as looking like scaly bumps or a honeycomb pattern. These formations are thought to result from convection, a process where warmer material rises, cools on the surface, and then sinks again, creating a cycle that gives the appearance of moving, living terrain. On Earth, this type of pattern can be seen in regions with convective forces, such as in mudflats or in large rock formations where heat causes expansion and contraction. The presence of similar features on Pluto suggests internal heat sources, possibly from radioactive elements decaying in its core. This heat may allow the nitrogen and other ices on Pluto's surface to behave almost like fluids, constantly renewing and reshaping the landscape over time. The idea of active geology on Pluto was unprecedented. Until the New Horizons mission, scientists believed that only planets much closer to the Sun, like Earth or Jupiter's moon Europa, could exhibit such activity. Pluto, in contrast, exists in an area of the solar system with extremely low temperatures, where sunlight is incredibly weak. Yet the presence of convective features on Pluto indicates that the dwarf planet is not geologically dead. Instead, it is in a constant state of subtle transformation, driven by internal heat sources that were previously thought to be impossible for a body as small and cold as Pluto. Another surprising discovery was Pluto's atmosphere, which appears far more complex than expected. New Horizons found that Pluto has a thin atmosphere composed mainly of nitrogen, with traces of methane and carbon monoxide. This atmosphere extends over 1,600 kilometers above the surface and is layered, with haze particles that give it a bluish tint when observed against the Sun. The atmosphere likely undergoes seasonal changes as Pluto's elliptical orbit brings it closer to and farther from the Sun over a 248-year period. When Pluto moves closer to the Sun, some of its frozen nitrogen, methane, and carbon monoxide thaw, releasing gases into the atmosphere. As Pluto travels farther away, these gases refreeze and fall back to the surface. This ongoing cycle creates a dynamic atmosphere that, although different from Earth's, behaves in surprisingly similar ways. It even snows on Pluto, though the snow consists of tiny particles of nitrogen and methane instead of water. The landscapes on Pluto are another source of fascination. In addition to the polygonal structures of Sputnik Planitia, New Horizons revealed towering mountains that reach as high as 3,500 meters. Unlike mountains on Earth, which are made of rock, Pluto's mountains are likely composed of water ice. At Pluto's frigid temperatures, water ice is as hard as rock, allowing it to form towering structures despite the dwarf planet's low gravity. These icy mountains give way to vast plains and rugged canyons, with evidence of ice flows and erosion. In some areas, such as the region informally named Cthulhu Macula, the surface is darker and more heavily cratered, suggesting an older, more stable terrain. One of the most visually stunning images captured by New Horizons shows Pluto backlit by the Sun, creating a glowing halo around the planet. This image, taken as the probe moved away from Pluto, allowed scientists to observe the layers of the atmosphere in remarkable detail. It also provided clues about the structure and composition of the atmosphere, with light scattering off small particles suspended in the thin air. This phenomenon is similar to the way sunlight interacts with particles in Earth's atmosphere during sunset, giving a unique and ethereal view of Pluto. The implications of these discoveries extend beyond Pluto itself. The active geological processes on Pluto suggest that other icy bodies in the Kuiper Belt, like Eris, Haumea, and Makemake, might also possess internal heat sources and dynamic surfaces. This changes our understanding of how celestial bodies behave at the edges of our solar system. These discoveries prompt scientists to consider that even distant and frozen worlds could have subsurface oceans or other forms of active geology, which could create environments potentially suitable for microbial life. While Pluto is unlikely to harbor life as we know it, the possibility of liquid water beneath its icy crust raises questions about what conditions might exist on similar dwarf planets or moons orbiting distant stars. The New Horizons mission has given scientists and the public a completely new perspective on Pluto. Far from the frozen, inactive world it was once believed to be, Pluto is now seen as an active, dynamic body with complex geology and climate systems that defy expectations for an object so far from the Sun. The insights gained from this mission underscore the importance of continued exploration in the outer reaches of our solar system. Every discovery challenges our assumptions and expands our understanding of what is possible in our cosmic neighborhood. Since the completion of the Pluto flyby, New Horizons has continued on its journey, venturing deeper into the Kuiper Belt and capturing images of other distant objects. In 2019, it flew by Arrokoth, a small Kuiper Belt object, providing further insights into the characteristics of these ancient remnants of solar system formation. Yet Pluto remains its crowning achievement, a mission that has changed textbooks and inspired new generations to imagine the possibilities that lie in the farthest reaches of space. The New Horizons mission has forever changed our view of Pluto. It has revealed a world with an atmosphere, active geology, and landscapes shaped by processes we once thought could only occur on planets much closer to the Sun. As a result, Pluto has captured the imagination of scientists and the public alike, proving that even the smallest and most distant members of our solar system have secrets worth exploring. These findings open the door to new questions about other icy worlds and offer a reminder that the universe often holds surprises far beyond what we can imagine. Through its exploration of Pluto, New Horizons has reminded us that even at the edge of the solar system, there is still much to discover. For those captivated by the mysteries of space, Pluto represents both an end and a beginning, a gateway to the unknown realms that await us beyond the edge of the solar system. Through its exploration of Pluto, New Horizons has reminded us that even in the farthest reaches of our solar system, there are still wonders waiting to be discovered, inspiring us to keep reaching for the unknown. Welcome to Space Lab, your gateway to the wonders of the cosmos. Here, we dive deep into the mysteries of space, exploring everything from distant planets to groundbreaking discoveries in astronomy and astrophysics. Join us as we unravel the secrets of the universe, one video at a time.